I'm Jordan,
And I'm Marina.
and this is our Part 1B project. Our sport focuses track and field jumpers, specifically the high jump, long jump, and triple jump. In Part 1A, we completed a needs analysis of these events, looking at the movement patterns, energy systems, and physiological demands. That analysis gave us a clear picture of what athletes need to succeed.
Today in Part 1B, we're going to apply the information to three main areas.
Demands of jumpers. Jumpers are among the most explosive athletes in track and field. Success in these events depends on three key qualities: explosive strength, sprint speed, and technical precision. Every jump starts with an approach run that builds velocity, followed by a powerful takeoff where triple extension at the hips, knees, and ankles generates either vertical lift or horizontal distance.
Finally, landings demands strong eccentric control to safely absorb forces that are often several times body weight. So then we think about jumpers. We aren't just training for power, we're training for controlled power and technical execution under pressure.
Hmm. Movement patterns and muscles. To support these demands, we structured training around the seven fundamental movement patterns. You see them listed on the slide, but let's think about what they mean for jumpers. Squats and hinges are essential for building explosive lower body power. Lunges emphasize single leg strength and balance, which directly transfers to unilateral takeoffs.
Push and pull patterns balance the upper body, keeping posture and arm drive efficient. Core rotation and anti-rotation help athletes resist unwanted movement and stabilize the trunk. And loaded carries improve overall stability, grip, and bracing. When you train all these patterns consistently, you target the glutes, hamstrings, quads, calves, trunk stabilizers, and shoulders. Every muscle group a jumper needs to generate force, control their landings, and stay healthy across a long season.
Energy systems. From a physiological perspective, jumping events rely heavily on the ATP-PCR system. This is the body's most powerful but shortest lasting energy system, providing explosive power for efforts under 10 seconds. The glycolytic system plays a minor role, helping with partial recovery between repeated attempts. And while the aerobic system isn't directly involved in the jump itself, it supports overall endurance.
Allowing athletes to maintain performance across multiple jumps in qualifying rounds and finals. So, training for jumpers focuses mainly on explosive, short duration power, but we don't completely ignore glycolytic and aerobic contributions since they help with recovery and repeat performance.
Warm up. A sport-specific warm-up is essential for jumpers. Our focuses are on three areas: mobility, sprint mechanics, and core activation. Athletes start with dynamic mobility, which are movements like walking lunges or hip openers to loosen up the lower body. Next comes sprint drills like ace skips, bounding, or high knees. These sharpen mechanics, reinforce rhythm, and prepare the legs for explosive running and takeoffs.
Finally, we include core activation with exercises like Pallof presses or balancing drills. These turn on the trunk stabilizers that protect the spine and allow efficient transfers of force from the lower to upper body. By the end of this warm-up, athletes are mobile, activated, and ready to perform, but also less likely to get injured.
NSCA testing order. Now let's move into the athletic testing. The NSCA emphasizes the order of test matters because fatigue can affect results. Testing should progress like this. First, non-fatiguing measures, then agility, then maximal power and strength.
Then sprints, followed by local muscular endurance, then fatiguing anaerobic capacity, and finally aerobic capacity. For jumpers, the most important categories are the first four: non-fatiguing, agility, max power and strength, and sprints. That's where our testing battery fits in.
Jumper testing battery. Here's our specific testing battery. We start with anthropometric measures like height, weight, and body fat percentage. These don't cause fatigue, but give us a profile of the athlete. Next, we measure standing reach height, which is critical for calculating vertical jump performance. Then comes a single leg hop for distance, a test of unilateral power, balance, and landing control.
After that, we test vertical and broad jumps, which directly measure explosive leg power. We then assess strength with 1 rep max back squat, since lower body strength underpins all of the power production. And finally, we run a 30-meter sprint, which reflects approach velocity, one of the biggest predictors of performance long and triple jump.
Test instructions. Each of these tests follows a standard protocol. For anthropometric measures, we record height, weight, and body fat percentage. For standing reach, the athlete stands flat-footed with one arm overhead. This becomes the baseline for vertical jump. The single leg hop is best of 3 trials per leg, measured heel to heel with controlled landings. The vertical jump is measured on a vertec or jump mat with performance calculated as jump reach minus standing reach.
The broad jump uses 2 feet takeoff. We measure from the start line to the heels at the landing. The 1 rep max squat follows the NSCA progression. Start with warm-ups, gradually increase load, and find the max within 3 to 5 attempts. The 30-meter sprint begins from 2-point stance, and we use electronic timing if possible for accuracy. These protocols keep our data consistent, valid, and safe.
So why these tests? These 6 tests were chosen because they reflect the exact qualities jumpers need. Vertical and broad jumps measure pure explosive power. The 30-meter sprint shows approach velocity, and the squat measures max strength, the base of power production.
The single leg hop reveals unilateral control and stability, which matter for both takeoff and landing. And the anthropometric and reach measures provide important baselines. Together, these tests cover the whole picture: speed, strength, power, and control. Everything a jumper needs to perform.
Normative data. Now let's look at the benchmarks. A strong college male jumper will usually record a vertical jump between 50 and 60 centimeters. For females, it's about 40 to 50. Broad jumps average 2.2 to 2.5 meters for men and 1.8 to 2.0 for women. For the 30-meter sprint, elite males are under 4 seconds and females under 4.5 seconds.
On the strength side, a squat between 1.5 to 2 times their body weight for men and 1.25 to 1.75 for women is considered competitive. Finally, for the single leg hop, men average 1.5 to 2 meters and women 1.2 to 1.6 meters. Comparing athletes to these standards tell us whether they're on track or if their training program needs adjustments.
So to wrap it up, everything up, jumpers rely on explosive power, sprint speed, and precision and precise technical control. Training around the 7 fundamental movement patterns builds a balanced base. A sport-specific format prepares athletes to perform and helps prevent injuries.
And our testing battery gives us the data to measure performance, identify weakness, and prescribe training with precision. By connecting these needs analysis from Part 1A to practical recommendations, we've created a complete plan for improving jumper performance. And here are references.